This is a switch. By the time we're done here, we will understand the primary purpose and functions of a switch. Now this is also a switch. No, not the little Lego guys that we're having plugged into it, the guy behind it. But it wasn't always this way. So back in the day, before switches were switches, they were called hubs. They looked the same, they felt the same, they weighed the same. They essentially did the same thing. That is, they received cable connections from all the devices that were plugged in. But the difference is back in the hub days, all they did was regenerate the signals. So if our Obi-Wan Kenobi right here sent a message over here to Luke, obviously in Jedi training because he still has his red Jedi helmet on, it would come into the hub. And the hub would simply regenerate that signal out all the ports. It didn't look at it. It didn't really care. It would come out here to this obviously evil green ninja and Luke. Now, the devices that were plugged in, which are represented by these guys right here, would get all of the communication, but they would only listen to the ones that were addressed to them themselves. So if Obi-Wan was talking to Luke, Luke would see that and go, oh, this is for me, I'll look at it. Whereas evil green ninja would normally ignore it unless he truly was evil. Because you could, if you were connected to a hub, get those messages, unpack them, look at them, and figure out what kind of communication was going on. But that's okay, because back in the day of hubs, people didn't do that. People were nice back then. Actually, the technical aptitude was just much less. So the chance of somebody being able to do something like that because they just wouldn't know what's going on was pretty slim, right? Nowadays, the technical aptitude has risen across the board for everybody involved. And that's where switches come into play. Switches are not only more secure, but also way more efficient than hubs. That's because every single one of these ports right here is assigned its own collision domain. Yep. Technical word coming right at you there. A collision domain just means it's separate from all the rest. The communication from Obi-Wan going into port 1 is only going to port 1 and whatever Obi-Wan has said as the destination. So if Obi-Wan wanted to communicate with Luke over here, the message would come in and just go out Luke's port. Green Ninja would be it would be in the dark because it would not get that communication. But whoa, wait a sec. How does Obi-Wan communicate to Luke? Obviously, we're talking about Lego guys right now, but let's talk about the switch. How does it know that port 15, or actually port 16 right here, is Luke? Well, each one of these guys is assigned its own unique identifier. We'll call it their code name, which we know as a MAC address. Obi-Wan, behind the scenes, is known as codename 00A159B62. It's a 12 character hexadecimal address. That's 0 through 9 and A through F as valid characters. So each one of these people, unique, burned in from the factory when Obi-Wan was manufactured, had a unique MAC address burned into him. And as soon as they communicate, as soon as they break silence and send a message into that switch, the switch learns their MAC address and puts it into something known as the CAM table. And that's where I want to pause for a moment and clearly define what is the primary function of a switch. It is to receive data packets, which are known as frames. By the way, everybody calls them packets. Technically, that's wrong, but the heart behind it is okay. They're called frames when they're going through a switch. I'll show you why in just a second. And directs those frames to their destination. So it connects the cables, which they don't plug into Legos. It plugs into the computers and the servers that we're working on. And it could be either copper cables, which is what we're used to seeing, stuff like this that plugs into our devices, or it could be fiber optic cables. I'll talk about that in just a second. It then learns by itself what MAC addresses are connected to that cables. Now, it could be one MAC address. If Obi-Wan plugs right in there, it's going to learn his MAC address, his code name. Or it could be multiple MAC addresses. Imagine we took this switch and connected it to another switch, and we plugged in all the Star Wars characters up there, right? As they communicated down to the Star Wars characters on this switch, it would learn all of their MAC addresses as though they existed on that one interface. It stores those in something known as the CAM table. That stands for Content Accessible Memory. That's just a table of MAC addresses and which port they're assigned to that's stored in the memory of the switch. Now, I did say memory, so that means if it loses power, what happens? Poof. All the MAC addresses are gone, and it has to relearn them. But normally that's fine, because by the time it powers on, those devices are so chatty that they'll add their MAC address to the table in the matter of seconds. The switch then decides, as those frames come in, whether it's going to forward or flood that data through the switch. Forwarding happens when it knows where that device is located. So when Obi-Wan sends a message in for Luke, and let's just say Luke's code name is 0002. I know it's 12 characters and so on and so forth. I'm just going shorthand. Obi-Wan's code name is 0001, right? When that comes into the switch, if it knows where 002 is, it will send it out that specific port. But if it doesn't, meaning Luke has gone on radio silence, right? He hasn't communicated. Each one of those MAC addresses is assigned a timeout value. By the way, most devices, most switches, it's 5 minutes by default. So if Luke goes on radio silence for 5 minutes, it will forget his MAC address. And so if it forgets it, it will flood it out all the ports. It'll say, hey, 0002. It's kind of like a hub, right? The very first packet will go to all of the ports. When Luke gets that and responds, now the switch knows his MAC address, adds it to that CAM table, is on port, let's just say 24 down there. Actually, that'd be more like 48, because that's a 48-port switch. And all the future communication between Obi-Wan and Luke is forwarded rather than flooded. Last thing I want to show you is this little guy right here. This is an example of what the information looks like when it comes from Obi-Wan and goes over to Luke. Let's say that Obi-Wan, on his computer anyway, was working on an Excel spreadsheet listing the location of all the rebel forces. Well, that Excel spreadsheet is the data. Now, just so you know, typically that Excel spreadsheet will be chopped up into a whole bunch of little packets. It might be hundreds or thousands of them, because these things are very small. Oh, see, I did it. I failed. I called it a packet. Typically, it's called a frame, but everybody's just so used to saying packet. That's what we do. I'll talk about packets later. So Obi-Wan figures out the destination MAC address for Luke. How that happens, I'm going to say, is magic right now. Now, we all know there's no magic. This little thing only works on the kids until they figure out how it works, and then it's not magic anymore, right? Now it's something that is a known thing. And when we explore the full scope of network communication, which we will in this skill, it won't be magical, but for now it's magic. So Obi-Wan figures out the code name for Luke, 0002, puts his code name, 0001, in that header, and sends it into the switch. The switch, which is a layer 2 device. Oh my goodness, I'm introducing so many concepts right now, it's scary. That is the Osi model, which is something that you will learn to love. It is 7 layers of goodness that describe network communication. Down at the bottom is layer 1, which is the physical layer. That's stuff like cables and Velcro strips and cups of coffee and all that strange stuff. That's all physical stuff, right? If there's a physical problem, what do you think it's going to be? Broken, right? You rolled over this thing with your office chair and it frayed the cable or something. Like that's layer 1. Layer 2 is the data link layer. That's where the MAC addresses are. So the switches sit there and learn the MAC addresses and then forward that data, that spreadsheet, directly between the people that need it. Oh my goodness, there's so much stuff I want to tell you, but I'm not. I'm going to restrain. I'm going to go back to this is a switch. And so is this. And so is the picture that I showed you on there. There's many different switches, many different models, and so on and so forth. Last thing I want to show you before we go on. I mentioned that these things connect cables, right? Now, the copper cables is pretty easy, right? You just take these and snap it right in. But you might be wondering, well, how do you do fiber optic cable? Good question. At the side of most of these switches, any decent switch anyway, will have these Sfp ports. Some people call them personality ports. Sfp stands for small form pluggable, where you can put in a module like this. This is an adapter for fiber. Slide it right in there, snap, and now you can plug your fiber optic cable in there. The reason they did that is because there's many different kinds of fiber cable. There's single mode, which goes farther, more expensive, multi-mode, easier to work with, cheaper. And the type of cable, the type of fiber that you're using will dictate which type of interface you need. So that's why they make these changeable. You can swap them in and out. Some of them will have, it's really common for them to have just 2 of those ports, because usually you'll use the fiber optic cable for uplinks. So when you're connecting a switch to another switch, could be a mile away in another building, it could be just down the hall, it could be right next to it. That's often where those fiber optic cables are used. You now understand the primary purpose and functions of a switch. It's to learn MAC addresses and forward data. I hope this has been informative for you, and I'd like to thank you for viewing.